I'm doing all right. Thanks for asking. Just trying to make sure all the windows are here appropriately. It's always a fun challenge getting these to present in the right order. Um, but we are at 1:30, so I'm going to start the recording here. And we are recording. Okay, great. Hello, everyone, and welcome to Lecture 14 for CSE 154. So I'll start off with saying I know we were going towards ed and these ed lessons and pre videos before lecture, and you've not seen any of those this week. It's because I've been trying to transition into them, and it takes some. That's been taking some work. So for the moment, we'll be doing these lectures, and then I'll provide extra videos afterwards to re-emphasize the important topics that we cover today. And so we heard from a lot of you that having the extra ed exercises was helpful. We also heard from a lot of you that it was felt like a lot of extra work. And so trying to balance those two, and I think I mentioned this on Monday as well. So we're trying to balance that a little bit. And making it feel less like the extra videos are extra work and more that they're helpful to learning the material. So we'll try to keep it that as much as we can. And so for today, we'll be talking about actually using Fetch with some APIs. Now that we've learned JSON, now that we've learned promises, we can get to some interesting things with APIs. Before we get there, a couple things on agenda items. We're going to do a slight review. Then we're going to go into Fetch with APIs, and a reminder that CP3 is out now. And some of these administrivia points and reminders to make. A lot of little logistics things, but we want to make sure that these are emphasized for everyone. So, couple things. When turning into Gradescope, using that GitLab button, please make sure it has all the correct files, file names, and directory structure, including all of the requirements on uppercase, lowercase, and where files are, and that there's not extraneous files. We see a lot of assignments that have extra files or files within other folders or in ways that we don't necessarily expect. So when you click that turn-in button, make sure to double check that it is what you think it is and that it's what the spec expects it to be. When you don't do that, it makes us giving you feedback take a lot longer. And so then the time between when you turn in and get your feedback is much longer as well. And so make sure to follow that. Now that we've had a couple homeworks under our belts, it's worth emphasizing again that per course policies, posting homework code or pseudocode or even really the specs publicly is explicitly prohibited by our course policies in our academic conduct section of the syllabus. So if you are using something like GitHub or Bitbucket or one of those other tools for managing your own source repository for classwork, that's okay. Just please make sure that it is set to private and not open publicly. I know it's easy to accidentally flip that bit back and forth, especially with people like GitHub having more private repositories open for people these days. But make sure that it's private or use a different service that you can't make it public because again, having that code public is a violation of our course policies. We can find them and we do see them out and about. So please do check if you have one of those repositories. As per the specs, a couple things there. One, the spec is very detailed, as you've probably seen, for all of our assignments, and it has a set of criteria and a set of tests and a set of things that it's looking for. That is what we are grading against for all of the assignments, and so when you submit, we are actually only showing a subset of the tests that we've used to finally grade. And you are expected to make up that difference, and not by writing tests necessarily, but by checking to make sure that your assignment is matching what the spec expects, and that you are properly passing the tests. We have seen some assignments where they've been turned in and they are not passing anything. Sometimes because of just a typo, like renaming a file and then didn't rename it everywhere, and so now all the tests are failing. So also make sure that when you submit the assignments that you've double checked the tests are passing. This also comes with a corollary of make sure you are submitting early enough that you have time to wait for the tests to run and for them to tell you whether they are passing or not. So if you submit at 10:59 and are waiting a couple minutes for that to pass, and then realize you've missed something, you are now past the deadline. So make sure you're actually submitting a little bit early to verify those tests. And finally, some of you may have noticed, but we changed the template on Ed questions so that when you create a new question, there are some prompts there, some questions for you to ask yourself when you are posing questions on Ed, and these are meant to help guide you on finding the answer yourself. And there's a couple reasons we do that. One is because we as the course staff can get burnt out pretty hard on answering a lot of questions. We have grading to do, we have lecture prep to do, we have other things that we need to be working on, as well as answering questions. So that's one. The other is that a big part of software development and web development is going out and being able to find answers for some problem that you're working on, especially when it comes to homework assignments. These are pretty detailed and pretty specific on what we're looking for. We'll cover the theory and the concepts in lecture, but when you're actually going out and doing the practice, a lot of those resources those answers are out there somewhere. And so the questions that we've provided in the Ed template are meant to help guide you to finding those answers. And then in the future, then hopefully by knowing how to do that and by having that pattern known within your fingertips, that you can it makes your own development a lot faster as well, because then you don't have to post a question, wait for an answer that's not exactly the answer you're expecting, so then you have to go somewhere else and then find another answer. So having this practice of being able to discern where the answer to your question is can also help speed up your work too. Okay, I have talked for a while. Are there any questions? Are there anything about either something about the things that I just talked about, or about JSON, or about fetch? I'm gonna pause momentarily for questions. Okay, it's looking like no questions. Um, so if you do, remember you can type hand in the chat, or or ask it there, and one of us will try to get to it there. Okay. Um, so now into the content. just to quickly review, we introduced a couple of things over the last week and a half or so. Yesterday and on Monday, we introduced this thing called JSON, the JavaScript Object Notation. It is a way to package and process and send and transfer structured data between different programs and different servers, different clients. We introduced AJAX, asynchronous programming. We didn't really talk about that term, but the idea that it embodies is being able to request data from a server from somewhere on the internet. And that first A in AJAX stands for asynchronous, and that's what we spent all of last week really working on was trying to understand this asynchronous nature of JavaScript, being able to use promises to be able to handle something that happens at some arbitrary time in the future, and this is the asynchronous. We then introduced this idea of fetch, and we kind of touched on it here and there a little bit as the way that we actually request data from a server. This is the API that we use to call APIs, essentially. And fetch itself uses promises with this .then chain of commands of functions to actually handle the requests. And so we ended up with this template that we started walking through, where we have I'll make this. Oh, that doesn't work. Okay, so we had this template where we have our fetch call that calls from a URL, and it checks the status code that's returned, and it optionally parses our response into text or into JSON. It processes that data and then potentially handles any errors. And so when we're working with APIs, most of our code is going to start with something that looks kind of like this, where we have this pipeline of fetch and .thens to verify the data and then do something with it. And so by talking about fetch, we introduced this notion of an API, and we talked a little bit on Monday and a little bit yesterday about what it means to be an API and how an API can be useful for a website. And so, really, for our purposes here, it's going to be a URL with optional parameters that returns some data for us. And this is all based on something called the client-server model, where we have a client. The analogy we've repeatedly used is a restaurant or ordering a pizza, and those are the clients, where the client has wants something and the server can provide it. And so APIs work in the exact same way. We have a client, which might be our website, and there's some server somewhere else on the internet that has some data that we would like. And we get that data and we can talk between this client and the server using APIs. All of it goes over the internet, and all of our clients can really be a little bit of everything. They could be other servers, they could be mobile phones, they could be websites on your laptop or on your desktop. And it's all just going over the internet using that HTTP protocol that we have mentioned a couple of times. There's this notion of a REST API, and we're not going to get too much into detail about it, but the general thing to know out of this is that we issue a request, and it has a couple of things about it. It has the parameters, it has the URL that we're requesting, it has the API method, or the HTTP method, and we will get into that later this week about what that means. It has any optional parameters, and then the web server sends back a response. This is really the core concepts behind our API. We send a request, we get a response based on what those parameters were. There's lots of APIs out and about, out in the internet. You can, in fact, search for public APIs, and there is this wonderful list on GitHub of public APIs categorized and contributed from people all over the internet. So, for example, if we wanted to have an API that just works with words or OWLbot words, I don't know what that is, but if you wanted an API that talks to a dictionary, that exists. If you wanted an API to talk to calendars, that exists. So there's tons and tons of these public APIs out there. Aman has a question about, could the request be denied for the API, and what would happen in JavaScript if it does? So this kind of comes back to, I don't have a slide on it, but I'm going to go to this website. It comes back to our error codes. And most of the time, we'll expect to get the 200 OK error code. So OK means just everything is fine. And so note that this is, we have 200 OK. And if we go back to our slides, and I'm going to go backwards over to our template, and I know the text is small, I apologize. The slide thing, I can Command plus as much as I want, and the text doesn't actually get bigger. The arrows get bigger, but the text doesn't. So I apologize that it's small. But if you look real close here, our check status function is checking if the response is OK. So that property on the response object is looking at these response codes and saying, was the response code OK, or was it something else? And a potential something else could be, it could be a 404 that it's not found. It could be a 403 that it's not allowed. We don't have permission to access that API. It could be a bad request, could have not the parameters that the API expected. Any of these reasons could be a denial. So 400 type error codes are you requested the wrong thing, or you didn't request it right, or you don't have permission to request it. These are things that the client can fix potentially. And so if one of those codes come out of our response, then our checked status, so if it's not OK, we throw an error. Now, what happens in a promise.then chain if there's an error somewhere in that chain? Yes, exactly. The catch method is called. So when check status has this error, and then it comes into the catch method, and then the catch is able to do something with that error. It might change something in the DOM to tell the user that maybe they had the wrong username password, or you could log something in the console to say that the API key is bad or something like that. But yes, the if it fails, the catch method will be called. Okay, so there's lots of different APIs here. And what we're going to do today, right now, is to look at actually using one of these APIs. And so I've pulled open already the NASA Astronomy Picture of the Day API. And this is one of those APIs that's just out and about, and it's free. You can go to api.nasa.gov, and it has some documentation, and then we have this Browse APIs section where we can go through, and there's all kinds of spacey APIs that we could potentially use. And one of them is this Astronomy Photo of the Day API. And they have, of course, their own website where you can click on it, and it has these lovely pictures of spacey things. And so here's one where it's this particularly high definition image. I can click on it, and it's nice and big, and it has this explanation and It's just got some simple information about whatever photo this is. So it's a nice simple API to try out and to test with playing with fetch and APIs. Um, so when you're looking at a new API, there's a couple things to try to discern for yourself. The first thing is, who do we ask? Because when we have that fetch call, the first parameter and the only parameter that we've seen so far is the URL. And so that's kind of the most important thing to start off with is, what is that URL? Every API is going to tell you in some way what that URL is. So here's a couple of examples. There's one where you can get random elephants out of an API. There's another one where you can get random information about numbers. So this elephants API, for example, gives me the information about a random elephant, which is kind of neat. The numbers API gives me random information about interesting numbers if it loads. It's kind of being slow today. So for the NASA Astronomy Picture of the Day API, when you go and look through it, most API documentation has one of these examples right up top. For example, here's an HTTP request. We're told that it's a GET. And again, we'll get to that a little bit later. And here is our URL. So that's first question, is what is the URL? We've got that. The second question is this: do we have permission to ask the API for its data? So this is kind of getting to your question earlier of there are scenarios where we need to set up an account or otherwise be granted permission by the API owner to call the API. Now, a lot of APIs don't have any kind of authentication. Like, again, this Elephants API, I can just have it open and hit refresh all day, every day, and get some random elephant facts. Like, I had no idea that they're, this is the jumbo elephant, apparently. That's convenient. But for our NASA API, when we look through the parameters, one of these parameters happens to be an API key. And so that's exactly what we probably want to look for. And there's some information here in the documentation about what DemoKey does. If we look up, documentation for all the APIs says that I can only get 30 requests. I'll make this a little bit bigger. Using the DemoKey, I can only get 30 requests per hour and 50 requests per day. Seems like a lot for when there's only a single photo of the day. I should only require it once. However, if I'm testing it, if I'm refreshing the page, if I have lots of users on my page, 30 an hour and 50 a day is actually very, very small. And so what they encourage you to do and what they ask you to do is if you scroll up a little bit more, you can sign up and get your own API key. And that makes your rate limits a little bit better, 1,000 per hour. And so that's quite a bit better. And if you need more, you can ask NASA for more. But for our purposes, that's going to be plenty. Some APIs will require that API key only does so many, and if it has any more requests after that, they're going to start charging you money. So when you sign up for an API, double check that it's not asking for your billing information so that you don't have to pay for it. That's kind of an important thing. Okay. So do we have permission? We have seen that Elephants does not require an API, but that NASA does. The next thing we want to know is, what do we need to ask? Every API is going to be structured a little bit differently. We can see, for example, the Elephants API has, it's small, so I'll come back over here. the elephants API has this /random on the end of it. And so what this is saying is that I want to call the elephants API and get a random one. That random is a parameter. It's a request for specific kind of API call. If I take that off, I'm just going to get all of the elephants. And that just happens to be how this API is structured. Other APIs will use what is called a query parameter. These are key value pairs, so kind of like our JSON, where we have that structure of some kind of key, like name, and then some kind of value, like fits. Query parameters are much the same. You often see these as showing up with a question mark, and then a series of something equals something and something else equals something else and something, something, something. It can continue for a very long time. These things are query parameters. And so in this particular example, the recipes API is saying that we're looking for the cupcake recipe and we would like a vegan one, for example. When we look at the NASA API, this astronomy picture of the day, we have a couple of options for what our parameters are. We have a date, we have whether we want it to be high definition or not, and then we have our API key. And so when we open this up, I'm going to click on that. All I've done is I'm still just using the demo key for now. I'll show, I've requested an API key earlier, so we'll show replacing it in a moment. But you can see potentially, again, I know it's small, I apologize. Up top there is a, pull that out. We have the question mark with our something equals something else, and I could add an ampersand. And there was that HD option. So if I give it a true, if I can type properly, so we have this HD URL, and I believe true. Oh, it is false by default. So what happens when we then change it to false? I would have expected one of these to change. Oh, it looks like it requires a capital T. Okay. So what I'm expecting to see here is that because I've looked at this API before, we have this HD URL parameter in property in our JSON. And so if we look at what this is, it's the name of the image underscore 1200.jpg. And our URL down here is 960.jpg. So I'm expecting that if I do the HD version, that these two URLs will probably be the same. And now that I have my capital T, it's still not. Which is curious. I wonder, it's possible that not all images here are able to return the HD images. So instead, let's look at the date parameter. So we'll do date equals 2020-04. Today is the 29th. So when I do that, I should get the same one. Let's go back a day to 28. And so we have our JSON here that says date is 29. We hit enter, and sure enough, now the date is 28. Now that I'm looking at a different one, let's try setting the HD parameter and still not doing what I would have expected. That's okay. We at least got the date to work. So these are our query parameters where we have definition of the API and the URLs and the query parameters, and then we can specify those as part of the URL, and so Aaron says, bit confused about what we were looking at exactly. So thank you for bringing that up. I meant to mention that earlier and totally glossed over it. I'm using a particular add-on here that is called JSON View, that is taking the output of that API and nicely formatting it for us. So if I it's already doing it. If I remove from Chrome, I'll just remove it. We can go back to having it later. And I refresh that. Now I just get this big old blob of JSON that's not formatted at all. I can't do anything with it, like highlight it or get any information about it. But because I had that JSON view extension, and now that I removed it, I'm going to re-add it. And then, oops, I'll just refresh the page. And now I have some nicely formatted JSON. This is a little bit more, this extension is doing a little bit more than just stringifying it. When I don't have the plugin, yes, it's just the stringified version of whatever object they were producing on the back end. And because JSON can be used across different languages, I have no idea what the photo of the day API is using on the back end, but they're sending me a stringified JSON object. And then my browser by default is just displaying the text here. And the JSON view, there's a few other ones, JSON formatter and others. This is just making it look a little nicer. So bolding the keys and making the values green like this. Not every API will return JSON. And so this particular API doesn't say up here, and it doesn't say down here. Usually API documentation will tell us whether it sends JSON or not. And that's why I'm showing, we haven't opened up any JavaScript yet. I haven't opened up the console. I haven't opened up a HTML file with a JavaScript source attached to it. I'm only looking at it through the browser. And this is a great way to start with testing out the API, because I just put this URL into the browser and hit enter, and I can see that it's JSON. And so now when I go and actually put it into my code, I'll be able to see that, or I can be able to use it as JSON. Not every API returns JSON, though. In fact, you can look through some of these, like the Exoplanet API is, I do not recommend looking into this API because when you call it, it returns this. This is most certainly not JSON. This is something called, it's a data table format. It's hard to interpret. It's hard to parse. Our JSON is going to be much easier. And so I don't recommend looking at the Exoplanet API because of this. APIs can return whatever they want. It just so happens that JSON is one of the more common formats. Does that help, Lauren? Excellent. Okay. And that's actually great. That answers our number 4 question of trying to understand what format we get the answers in. Once we have answers to all 4 of these questions, we have our URL, we have our API key if we need one, we have our parameters if we need them, and we have what does it return. Then we can actually get into putting it into our code. And so at this point, I'm going to drop over to this, and you can see in the URL that this is a file, a local file that I have on my machine. And right now, if I click the button, nothing happens. I can put in a number for the date. I can click the button, nothing happens. And that's because I've not done anything with it yet. So I'm going to pull up the code. This is the code for it. And as I mentioned earlier, I've already gone through and created an API key. And what we have here is just a really simplified JavaScript file for us. So we have our normal add event listener. We have an init, which finds a button by ID. It adds this event listener from our fetch. And then we have some of our placeholders, our helper functions. So as my slides said, what we really want is to start with this. I'm going to copy that in and paste it here. So we have a couple of things here. We're taking our request string, which I'm actually going to make it match what my code is doing. We have our URL, plus we have our API key, which I will make the API key. And then we're requesting a specific date. And instead of looking that far back into the past, let's look at, say, the beginning of this month. So now we have parts of our structure here. We have our check status. And I have an extra curly brace. So I'm going to remove that. Now my errors have gone away. Great. We have our check status. We already know from going through this list of questions that we have our API key. So I'm going to renumber these. This was question 1. We check status always. We always want to check our status. We have number 2, which is our API key. 3 will be what type it returns. And then we can actually do something with it, which is going to be our process data. And if I go and look at that function, which does not exist yet, so we can create it. This is going to take what? Let's remind ourselves what this function in the .then chain, what does it receive? JSON? Where does it receive the JSON from, though? Right. So we receive it from the previous .then in the promise chain. Exactly. So in this one, right before it, we are parsing whatever that response is into JSON. And so within here, we can just test this out real quick. We can say console log data dot, and if we go back to the API reference for picture of the day, actually, let's look at our example response. We have a couple parameters we could maybe look at, like the title. So we can test this out by just getting the title from our JSON. Go back to this. We'll refresh, click the button, and I'll have to open up the inspector and the console to see that is it an asteroid or potato. Huh, okay. And that was for the beginning of the month. So I'm going to change the 28 to a 1. And sure enough, yes, that matches our title. So This has now validated that this JavaScript code is calling that API successfully with the parameter we gave it and doing something with it. But we haven't yet finished because if we open up the HTML for this, we kind of have some implications about what we want to do with the data. For one, we have this input, which is getting the particular day that we want. So that's one thing that we need to do in our make request function, is to get out that input. The second thing we need to do is that we have this response div, which seems like maybe we could do something with. We look at our page, it's nicely styled to show that we have this square to put some response in. So let's start there, and then we'll look at the input box. I don't have the QS helper defined here, so I'm going to have to document dot query selector to get the response. Oh, it's actually an ID. So I don't even need to do that. I can do the ID of response, get rid of my extra parentheses. So response div is that. And then just to start off with, I can maybe do response div dot text content equals, let's do the stringify version of our data. So that at least we can tell that we are properly parsing it and putting it into the right place in the div. So I'm going to refresh this, click the button. Sure enough, I get my JSON there. And so with this, you can start to see how we might be able to use our normal DOM manipulation functions in combination with the result from our API to try and do something interesting um, uh, with the API data. We could add a new DOM element here, which is the image. We could have a new, we could make this input, this input, we could make it not a text field, but a drop down to get recent images. We could make it a search to find certain kinds of things using their API. And so this is generally what we're trying to look at, where we're using fetch to retrieve someone else's data. Other questions so far? Is there another way to store the API key if we don't want it to be visible for anyone checking the source of our page? That is a good question, and it's one that's hard to answer because, as you've probably discovered, anyone can go to any page and open up the inspector and open up the sources tab and start clicking through all of your source, and get that data just fine. So just having your API key in there is not always a great thing. When we get into talking about backends with Node, which we are going to start next week, I believe, that is one option for having the API key stored not on the source that everyone can see, but maybe in the source that only you can see. That's one good option. And that's usually the way that these happen, because otherwise, yes, someone could take your API key and make any number of requests on their own. There are other ways. We're not really going to cover them, but we'll talk about it on the back end part of it. Other questions? I it's I it's not allowed. Just it's not allowed. We'll just scroll up a little bit and ignore that one. Here's a found cat. Um, okay, so this is going to be our pattern, and for CP3, this is the expectation that we'll use this pattern, we'll use that template that we introduced here at the beginning to have our fetch, have our check status, have our process data to do something interesting with an API. And to answer your question, Lauren, yes, very possibly when you fetch from an API or fetch from a site, that site might be fetching from someone else as well. Um, sometimes we'll know that, but for the most part, we won't know. And that's part of the beauty and wonder about an API is that we don't have to know. We just get the data, and how they got the data is kind of irrelevant. Like we trust that they own the data and they have permission to share that data as well. But they can do whatever they want on their side to process the data, pre-process it before sending it to us, assemble it in some ways, fetch from some other site. They can do whatever they want with it. So yes, to answer your question shortly, it is possible. So I already mentioned this. Going into Chrome and using an extension like JSON View is really helpful. I will also note that some of this is kind of built into Chrome already. So if we open up the console and I'm going to refresh again, we go to this network tab. This is not one that we've really looked at yet, but this network tab provides information on where this site that you're requesting came from and how long did it take. So in this particular example, we're seeing that doing the APOD API gave us a status 200, which is great. It was successful. And it took about half a second. And what we can do here, I'm gonna make this smaller so that I can make this bigger. Um, when you double click on it, you can get some more detailed information, like a preview of the response. You can also see things like all of the headers, all of that additional information that gets sent and sent back when you call an API or even just request a website. So you can see that the API for the NASA, or the API at the IP address for the NASA API is this. Returned us this code, which we already knew, and we have a bunch of response headers as well. How long the thing is, that its type was JSON, so we can check this page to see what type it is. We also get the raw response, and there's this nice little button down here called Pretty Print, where we can click that, and sometimes it works better than others, and it's not working here for this one. Sometimes you can click that button and it works to make our responses look better. But the preview did that as well, so that's helpful. Chrome DevTools has lots of different tools, which is very helpful for inspecting what's going on with your API. This will be even more important when we get to forms and other kinds of API requests. So we looked at the NASA API. There's lots of different APIs out there. There's this data for searching about words API. There's NextKCD API, which returns JSON for the current comics, for example. Lots of different things have APIs, and it's kind of fun to look around and see what different ones do. Okay. That's our time. We've hit the end of our time for today. Thank you so much for being with us and talking through APIs. If you have any questions, please reach out to us on whatever platform you like to reach out to us on. So thank you, everyone. As normal, we'll stay on for a few minutes to answer any lingering questions.